Hello, wonderful viewers. Welcome to Science Blood Online class. Okay, what do we have for today? This is Chemistry 101 past question. So, without wasting much time, the first question we are having here says, how many moles of carbon dioxide molecules are contained in 7.54 gram of carbon dioxide? So, the first thing we should do here is to apply the formula that says moles moles equals, we have the mass over molar mass. So let's say for instance m means what? Molar mass. Okay, without wasting much time again, we have mole equals, the mass given to us here according to this question is 7.5 gram. 7.54 gram. Again, the molar mass of carbon dioxide, we are going to solve this one separately. And this implies CO2 equals carbon is the mass of carbon is 12 plus the mass of oxygen is 16 multiplied by 2 atoms of oxygen according to this chemical symbol of carbon dioxide, which is 2. Close bracket. Okay, let's continue. So here we have 12 plus. Okay, so let us make use of our calculator so that we can be more faster on this. So here we have 16 times 2 equals 32. Here we have you have 32, therefore 16. So we have 12 plus 32 will give us 44. So the molar mass of a carbon dioxide here is 44. Okay, let us go back to our initial equation, which says moles equals, we have the 7.54 all over 44. All right, the moles equals, so once we point this in our calculator, let's see what we have here. We have 7.54 divided by 44, and this is approximate to 0.171 moles. Okay, 0.717 what? Moles. So the number of moles, or the number of moles on this compound, which is how many moles of carbon dioxide molecule contained in 7.54 gram of carbon dioxide. So this is the final answer for this question number 1. Please copy it very fast. Let us continue. Don't have much time. So let's move to the question number 2. Question number 2, which says, how many grams of copper are there in 2.55 moles of copper? Okay, all right. For this second question, which is question number 2, the same formula will be applied as well. Yes, the same formula will be applied as well. So we don't need to waste much time on this second question. Okay, if you are done copying this, let us clean it. Let me clean up this. I just put second question here. Is the question number 2. So we got the same formula. Then I will now start from here. Like I said, question says of copper. Okay, upon this question here, since the moles is given as 2.55 equals, mass is the one we are looking for. So you can just use a gram G to represent it. Then the molar mass Molar mass of copper, which is 63.5. 63.5. So upon this level now, we just cross multiply. So when you cross multiply, you have G, which is the gram, equals, we have the 2.5 multiplied by 63.5. Okay, let's continue. The gram equals, so upon this level now you have to make use of your calculator. So, okay, let us point this on calculator. So, which we have 2.5, 2.55 times, you have the 63.5, which is approximate. I'm here is 161.925 gram. So that is it. So the number of gram in copper in 2.55 moles of copper is 161.925 gram. So this is it for this. Okay, let's continue for the third question. Hope you are done with this. Let me clean up this. For the third question, we say we should calculate the percentage by mass of phosphorus in phosphorus trichloride. Okay, trichloride. So this is the chemical formula for phosphorus trichloride, which is PCl3. So this is the chemical formula for phosphorus trichloride. So, but the question is asking us to calculate the percentage by mass of phosphorus. Therefore, percentage by mass of phosphorus is equals the molar mass or the mass of the phosphorus over molar mass of the phosphorus trichloride. So, without wasting much of their time, and this implies we have a percentage of phosphorus equals, then mass of phosphorus is 31. Is also given, look at it here, inside this question, all over. Then the molar mass of this, let us solve it here. Have the 31 plus 35.5 times the 3 atoms of the chlorine. 3 atoms of chlorine, and this implies 31. Let us make use of our calculator so that it's more faster. So 35.5 times 3 will give us plus 106.5. 106.5. Okay, when we add both of them together, we have 106.5 plus 31 will give us 137.5. Okay, let's continue. So here's supposed to be 137.5. Multiply everything by hundreds over 1. Okay, so therefore, percentage of phosphorus, we now have 31 divided by 137.5, which is automatically, so look at what we are having here, then multiply by 100, When you multiply by 100, so we have 22 point, just say 22.5, 22.5%. So remember, since we are solving for the percentage of phosphorus upon this upon what? Phosphorus tri what? Chloride, which means everything, your final answer will be in percentage. So this is why we have 22 points. 22.5%. Okay, this is the final answer for this question, and which is the question number 3. All right, let us move on. Move to the question number 4. Question number 4 says determine the oxidation number of manganese in KMNO4. All right, KMNO4. Okay, let us solve this as well. Let us solve this as well. So, for this number 4 question, we have been asked to calculate the oxidation number of manganese in this compound KMNO4. So, for a problem like this, look at what the first thing you should do. You have to split all these elements in each summation form. And this implies potassium plus the manganese plus oxygen Remember, under oxygen here, according to this we have 4 atoms of oxygen here. So what next? Let us apply its valence what number. So for the potassium, the valence of potassium is 1 plus manganese is the one we are looking for. So we just call it what? Mn plus, then here we have oxygen. The valency of oxygen is -2, so we are going to put bracket here, -2 times 4 atoms of oxygen, which is this way, equates everything to 0. Let's continue. So here we have 1 plus Mn, so -2 times 4 will give us -8 equals 0. So upon this level now, we are going to collect items. Therefore, we have Mn plus 1 minus 8 equals 0. Mn 1 minus 8 will give us automatically -7 equals 0. So let's continue. This -0 will cross the equal sign. Therefore, we have Mn equals 0. This is -7 crossing the equal sign to give us +7. Therefore, final answer M equals 0 plus 7 is what? Automatically 7. So here we have +7. So which is the oxidation number of manganese in this compound, which is KMNO4, is +7. Okay, please copy fast. Let us move to the question number 5. Question number 5. Question number 5. And question number 5 says, what is the oxidation number of chromone in this compound? Okay, let me clean up this. Alright, so question number 5 is the same thing as that of number 4. Okay, but what is different is what? The compounds, okay, given to us. What is the oxidation number of chromone in this compound? So the compound we are having here is K2Cr2O7. or 7. Remember, like I used to say this, the first thing you should do whenever you're asked to calculate the position number of any element in a given compound, the first thing is what? Split the compound in its summation form. Then the second step, we should apply its valence electron or valence number. So upon this question here, let us split this compound. We have K2 plus Cr2 plus O7. Okay, so always remember to equate everything to 0. So the valency of potassium is what? 1 multiplied by 2 atoms of potassium, which is times 2, plus the one you are looking for, which is Kr. So we are going to multiply 2 by Cr plus, so let us open a bracket here. The valence of oxygen is minus 2 times 7 atoms of oxygen, close bracket, equate everything. Please always remember to equate everything to 0. So let us multiply out. Here we have 1 times 2 will give us 2 plus 2 times Cr will give us 2Cr plus, okay, let's see what we have here. Minus 2 times 7 will give us minus 14. Equate everything to 0 as well. Let's continue. So what next? We are going to collect like terms. So we have 2Cr, 2Cr plus 2, what next? Minus 14 equals 0. So 2Cr, 2 minus 14 will give us minus 12 equals 0. So let's continue. Here we have 2Cr equals, so this is minus 12 crossing the equal sign to give us a positive sign, which this implies 0 plus 12. So 2Cr equals 0 plus 12 will give us a plus 12. So we are going to divide both sides by the coefficient of Cr, which is 2. And this implies here will be 2, here will be 2 as well. So on the left hand side, 2 will cancel 2. We are now left with Cr equals 2 will divide itself on the right hand side to give us 1. Divide plus 12 to give us plus 6. To give us plus 6. So the oxidation number of chromium in this compound is plus 6. Okay, please always try to like, comment, and also invite your friends to subscribe to my channel and also follow me on Facebook as well. Do not forget, I am your science blog, always ready to give you the best. Bye bye.